Hey folks, today's topic is the binomial theorem. So the idea behind the binomial theorem, we do a lot of expanding of binomials. So you have something like x plus y to the sixth, 3x minus 4y to the fourth. And this guy by the name of Blaise Pascal, came up with a trick that he found after he expanded these over and over and over again. Like normally you'd have to write this 6 different times, distribute the first two, take that, distribute the next, then take that and distribute to the next, and then take that to go until you do all 6 of them. Then you have this big long statement that has a bunch of like terms that you can combine. Well, at the end of it, Pascal discovered that there was a pattern. And so he connected this pattern back to this thing that's now named Pascal's triangle. So let's first discuss Pascal's triangle. So Pascal's triangle starts with a 1 in the middle. Then the next row has a 1 and a 1. The next row has a 1, a 2, and a 1. The next row has a 1, a 3, and a 1. And it's really important that you draw it exactly the way that I draw it, because that's going to help you figure out how to find the next row in Pascal's triangle. Okay, so up to this point, it kind of seems pretty easy. Most people would guess that the next row would say 1, 4, 4, 4, 1, but it says 1, 4, 6, 4, 1. Now step back and try to look at the whole triangle at this point and see if you can figure out where the 4 came from and where the 6 came from. And my hint to you is look at the row before it. Okay, hopefully you caught on. So the next row would be 1, 5, 10, 10, 5, 1. And you'll notice what I did here. To get the new row, you take the two things that are above it in that space, add them together, that goes in the middle. So 6 plus 4 is 10, that goes in the middle. 4 plus 1 is 5, that goes in the middle. 1 plus nothing is 1, which then goes in the middle. See if you can generate the next two rows. You should get 1, 6, 15, 20, 15, 6, and 1. And then 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so Pascal's triangle, why is it so helpful? Well, it turns out that these are the coefficients of binomials getting expanded. I mean, let's do an easy one like x plus y squared. Well, x plus y squared would be x plus y times x plus y, which when I distribute, x times x is x squared, x times y is xy, and then y times x is another xy, so there are two xy's, and then y times y is y squared. Notice what the coefficients are, 1, 2, 1. Now go to the row. Pascal's triangle is kind of goofy. It starts with row 0. So this is technically the 0th row. This is the first row. This is the second row. I just remember it. Whatever row I want is the one that has that number in it. So like row 2 has the 2. But look at the coefficient. Look at the numbers in row 2. 1, 2, 1. 1, 2, 1. All right. So that's the idea behind expanding of Pascal's. So there's these two tricks. First of all, the coefficients will be whatever's in that row. So if this is to the 6th, I'm going to go to the 6th row and I'm going to list all those coefficients. And then the second trick is look at what happened to the first term. The x started with the squared. So x squared, and the y, the second piece, started with none of them. So there were two x's and 0 y's. Then it went 1x and 1y. So the x went down by 1 and the y went up by 1. And then the last one, the x went down by 1, so there were no x's, and the y went up by 1, so that became y squared. So let's try it with this first one. So first of all, I'm going to list my coefficients. Coefficients, I'm doing this row. Now spacing is always kind of weird here. Okay, so I've got 1. I want to have all the x's and none of the y's. So that's 1 x to the 6th, and there are no y's. Plus, and it's always plus, and now it might come out to be a negative when you clean things up, but in this one, This one doesn't have any coefficients, so everything's going to be plus. My next term is 6. Now this term goes down by 1, and the second term goes up by 1. So there were 6 x's before, now there are 5. There were no y's before, now there are 1. Plus, my next coefficient is 15. The x goes down by 1. The y goes up by 1 in exponents. The next coefficient is 20. The x goes down by 1. The y goes up by 1. The next coefficient is 15. X goes down by 1. Y goes up by 1. The next coefficient is 6. X goes down by 1. Y goes up by 1. Plus 1. The x goes down by 1. So now there are 0 x's, and the y goes up. So there are now 6 y's. It's pretty terrible, 6, but maybe I can rewrite that. That's a 6. All right, so there's the basic idea. Now, our first example was pretty easy. There were no coefficients. So let's take a look at one that does have some coefficients. So, okay, so to the fourth. So I'm going to the fourth row. So that's 1, 4, 6, 4, 1. I'm going to start with, oh, by the way, going back to this one, you don't have to write the ones here if you don't want to, because, 1 times x to the 6 is just going to be x to the 6. If it helps you understand it better, go for it. So I'm going to have 1. Now it's going to be the first term is going to get all 4 of them. The second term doesn't have any. It's always plus. Now at the end when we clean it up, it might not be plus, but that's okay. We'll deal with that when it comes to it. 1 and then 4. The first term, which is 3x, goes down by 1. That's 3. The second term, which is negative 4y, goes up by 1 to the first. Plus my next coefficient is 6. The 3x goes down by 1. The negative 4y goes up by 1. Plus my next coefficient is 4. The 3x goes down by 1. The negative 4y goes up by 1. Plus 1. The 3x goes down by 1, so there are none of them. And the negative 4y goes up by 1, so there's all 4 of them. All right, now it's time to clean this up. So we have things that we can put together. Keep in mind here, who's getting raised to the 4th power? Not just the 3, not just the x, but the 3 and the x. So I'm going to calculate my coefficient first. So I'm going to put the 1 in there just to help us, just for the sake of cleaning it up. 1 times 3 to the 4th. So what I do is I type this in exactly as it looks without the variable, and I get 81. So this is going to become 81 x to the 4th. And then I go back and count up how many of each one I have. By the way, I guess I didn't say this up above. Notice, what do the exponents in each term always add up to? 6. 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. 2 plus 4. They always add up to the overall exponent. Same thing here. There are 4 of these and 0 of the other. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 and so on. Okay, so now the next one. So I've got a 4 times the quantity of 3 to the 3rd times the quantity of negative 4 to the 1st. That gives me negative 432. Now I'm going to move this out of the way so I can write clearly. Negative 432, and then I just count up how many I have of each variable. I have 3 x's, and I have 1 y. Okay, now I do it again. 6 times the quantity, 3 squared, times the quantity negative 4 squared. Now remember, it's important to put negatives in parentheses when you're taking them to powers. We get positive 864. Go back through, there are 2 x's, there are 2 y's. And hopefully you get the idea to finish the rest of this on your own. So 4 times 3 times negative 4 to the 3rd, negative 768, 1x, 3 y's, and then finally, negative 4 to the 4th. Notice I didn't put the 1 in there. You don't have to because the 1's not going to change anything. Plus 256 y to the 4th. I'm going to encourage you to pause here and try to do example 3 on your own. All right, let's see how you did. So I'm going to the fifth row. So that's 1, 5, 10, 10, 5, 1. I'm going to scoot that up so you can see better down here. So my first coefficient is 1, and that means I have 2 x's to the fifth. Plus my next coefficient is 5. 2x goes down to 4. The negative 3 goes up to 1. Plus 10. 2x goes down to 3. The negative 3 goes up to 2. Plus another 10. The 2x goes down to 2. The negative 3 goes up to 3. And in my head, I'm always making sure these add up to 5. Plus 5. The 2x goes down to 1. The negative 3 goes up to 4. And then finally, I have 1 times negative 3 to the fifth. Now I need to calculate each one of these. 2 to the fifth is 32, so I have 32 x to the fifth. 5 times 2 to the fourth times negative 3. So negative 240 is my coefficient, and I have 4 x's. Oh, that's it. 4 x's. This doesn't have a y. I guess that makes sense. 10 times 2 to the third times negative 3 squared. Positive 720. 3 x's. 10 times 2 squared times negative 3 cubed, negative 1080. I have 2 x's. 5 times 2 times negative 3 to the fourth, 810. And then negative 3 to the fifth is negative 243. So think about that. I mean, look at how much nicer Pascal's trick is compared to expanding that by hand. You'd have to write that out 5 times and distribute one term or one parenthesis to the next parenthesis. That binomial, get a product, clean it up, then distribute again, blah, 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 blah. Okay, so find the fifth term of 2x plus 3, y, quantity to the 15th. So if you want to, go ahead and make Pascal's triangle, go all the way down to line 15. You might need a pretty wide piece of paper to do that. Or you can do this other trick called the alternate Pascal's triangle. Now, I don't know if you remember this from last year. This is called choose. This is the number of how big your group is that you're choosing from. This is how many you're choosing. And then the answer is how many different ways you could choose that many people. So, for instance, the first choose, like we did over here, row 0, 0, choose 0. Now let me first show you how to find 0, choose 0. So I'm going to go to my calc. I'm going to go to math. I'm going to go over to PRB, and then you have NPR and NCR. Make sure that you're choosing the right one. We want NCR. Oops, I messed up. So I'm going to put the 0 in there first. Sorry. Math, go over to PRB, go down to choose, and then put the other one at the end, 0 and 0. 0, choose 0 is 1. That makes sense. How many ways could you choose nobody from a group of nobody? 1. Don't choose anybody. Okay, now the second row is 1, choose 1, and then 1, choose 0. So you always start off with how many you're going to choose, and then you go down by 1 until you don't have anything left. Second enter, I'm going to change these to 1s. 1, choose 1 is 1 way. From a group of 1 people, how many ways could you pick somebody? You could pick that person. How many ways from a group of 1 person could you pick nobody? 1 way. Don't pick that person. So that's also 1. So far we've generated 0, choose 0 has been this. 1, choose 1 has been this. 1, choose 0 has been that. So now we're going to go on to the next row. 2, choose 2. 2, choose 1. 2, choose 0. So how many ways from a group of 2 people, 2, math, PRB, choose 2. How many ways from a group of 2 people could you choose 2 people? 1. You got to choose everybody. If there's only 2 people to pick and you got to pick 2, you got to pick both of them. 2, math, PRB, choose 1. There are two ways from a group of two people to pick one person. You could pick the first person or you could pick the second person. That's why this is 2. How many ways from a group of two people could you choose nobody? Only one way. You don't choose anybody. So look at what we just generated. 1, 2, 1. Look at our second row. 1, 2, 1. And let's do one more row so that you can believe me that this works. 3, choose 3. 3, choose 2. 3, choose 1. 3, choose 0. 3, choose 3. Only one way. You got to choose everybody. 3, choose 2. There are 3 ways. 3, choose 1. There are 3 ways. And then 3, choose nobody. What are our coefficients? We lost the other one, but it was 1, 3, 1. 1, 3, 3, 1, which is 1, 3, 3, 1. So whatever power I want to pick, I can start with that choose. So for instance, the 15th row of Pascal's triangle will start with 15, choose 15. Just like the third row started with 3, choose 3. The second row started with 2, choose 2. The first row started with 0, 1, choose 1. The 0th row started with 0, choose 0. So the 15th row, where's that going to start? That's going to start with 15, choose 15. But I want to go to the 5th term. So the first term would be 15, choose 15. Then it would go to 15, choose 14. 15, choose 13. Just like this went down by 1 each time. So I'm going to count on my fingers how many I'm going to have. So 15, choose 15 is the first one. I want the 5th term. So I should have 5 fingers up. 15, choose 15. 14, 13, 12, 11. So the 5th term would be 15, choose 11 times. Now, folks, that only gives us the coefficient. That only gives us the coefficient. That's this number out front, the 5 or the 10 or the 10 or the 5 or the 1. What we now need to do is we need to take 2x and we need to raise it to an exponent. What exponent would we be at if we were in the 15th row? Well, the first term would have a 5. Look at when it's a 5. The first term has a 5. Then it goes down by 1 until it gets to 0, and there are none of the first term. So in a row 15, the first term should be to the 15th, but we want the 5th term. So the 15th, the first term would be 15, second term would be 14, 13, 12, 11. Again, we get 11 as the 5th term. So one of the checks that you can do is you can compare these two numbers. These two numbers should always be the same number because 15 choose 15 starts off as our choose, and then to the 15th power starts off as our exponent. Now, here's the other thing to remember. What did we say about all the exponents? What do they always add up to? They always add up to whatever your overall exponent is. So our overall exponent is 15. That makes it real easy for me to figure out what the rest, how many of these, how many 3y's, how many of my second term do I need? Well, if there's 11 already being used, then 4 is what's left over. Okay, so now we have to compute what this coefficient actually is. We need to get what the number is here. So I'm going to do 15, math PRB, choose 11, times the quantity of 2 to the 11th, just like we did before. We're ignoring the variables right now. 3 to the 4th, and we get this massive number. Let me do my commas. So that's 226 million. So 226,437,120. And then I go through and I count up how many x's I have and how many y's I should have. I should have 11 x's and I should have 4 y's. Okay, I'm going to encourage you to pause here and try to do the next one on your own. Okay, let's see how you did. So first of all, I'm going to the 11th power, so it's going to start off as an 11 choose. 11 choose, I want to go to the 8th term. That doesn't mean I stop at the number 8. That means I should have 8 fingers up after I'm counting. So 11 choose 11 is the first one. Then 11 choose 10, 9, 8, 7, 6, 5, 4. So 11 choose 4. times my first term is 3a. Remember, the exponents of these would be the same, or you can count through it again. My second term was negative 4b. 4 plus 7 adds up to 11. Okay, now I have to compute what this number is. So I'm just going to put it over the top. 11, choose, I already forgot. 11, choose 4. 11, choose 4 times the quantity of 3 to the 4th times the quantity of negative 4 to the 7th. Yeah, there we go. So you get a pretty big negative 437 million. So my coefficient is negative 437,944,320, and I should have 4 A's and 7 B's for a total of 11 as my degree. All right, so you can add these to your unit circle. You can add these to your Unit 5 reference sheet if you want to. Feel free to put them on there. You know, once you get the idea, you can just generate Pascal's triangle whenever you need it. But if you want to add these, go ahead. All right, good luck.